Hi there, this is Haley Hogan, and I'm here with our Permeable Pavement Masterclass speaker, David Hine, talking about his upcoming 4-session Advanced Permeable Pavement webinar series. So Dave, why should we be using permeable pavements?
Well, number one, if we've got soils that are open and fairly coarse graded, like sands, think Kitty Hawk, North Carolina, Corpus Christi, Texas, out on the coast of Oregon, all of these places that have sandy soils, anywhere along major rivers typically, Mississippi, Hudson, whatever, all of those areas have very coarse soils that allow water to get back into the ground very quickly. And so in areas we call percolating soils, we basically increase the water into the ground. If we can infiltrate it into the ground, then we're actually solving our problem just about right off the bat in terms of both quantity and quality of water. During high storm volumes, we're trying to detain water. Many of the regulations out there say we want you to capture and store and detain the first flush or the first inch or inch and a half of water during a major storm. Typically, in most areas of North America, the inch and a half of 25, 40 millimeters worth of water is about 98% of most of the design storms or most of the typical rainstorms that we have. And so the goal is to detain that and to have it not leave the pavement surface as soon as it hits it, but to rather store it, keep it underground, contain it for 24, 48, 72 hours, and then gradually release it or infiltrate it or release it into the to downstream. So we don't have these big peak flows where we have a stream that is maybe a foot deep and all of a sudden is going to be 30 feet deep in water like happened in Atlanta a few years ago. We also want to clean the water, reduce the stormwater pollutant load. If we can intercept it, if you think about taking yourself a water bottle and putting a bunch of dirt in it and shaking it up, the whole water bottle is going to turn brown. If you sit it on your desk, on the floor or whatever, and you leave it there for a couple hours, you're going to find that all of that water, all of those silty particles and stuff that are in the water are going to settle out to the bottom, basically gravity working. And you do that, you're cleaning the water above it because moving water is going to hold that stuff in solution, whereas standing water or water that's moving very slowly will tend to drop particles out of solution, thereby cleaning that water. And so we do that, and we can also do things like, as a part of that process, rather, we're removing things like phosphorus and nitrogen and a bunch of other things from the water stream. Finally, decreasing downstream erosion. By doing this, again, we make the water less volume, we make it move slower, therefore we're reducing the amount of erosion, reducing the amount of particles and dirt in the water stream.
Okay, yeah, we hear a lot about these benefits and about permeable pavement in general. So Dave, are permeable pavements new?
Permeable pavements, again, they're not new. These things have been around for an awful long time. In Europe, they've been using them for 30 years plus. The oldest permeable pavements in North America are almost 100 years old. So this is not something that's new. There were a lot of failures in the past of these things. We know certainly how to do it better nowadays and build it right. It's a cross, though, between the water world and the pavement world. And very frequently I go to water conferences and whatnot. I'm the only pavement guy there. I'm seeing that change nowadays. So we're starting to get more discussion and topics between these. It's just making sure that we're careful that we understand what we're building and where we're building and how to make sure these things survive.
Yes, and I'm looking forward to learning more in your sessions. The good, the bad, and the ugly is my favorite. So for those who are new in our audience, what types of permeable pavements are out there?
So I mentioned the words pervious, porous, and permeable. The concrete industry typically calls their stuff pervious concrete, the asphalt industry porous asphalt, and the paving stone industry permeable interlocking concrete pavement, PICP. There are many different kinds of pavements like this. All of them have, again, good applications and good places to be used. Some have some benefits in certain areas over others. Regardless, the whole intent of these type of pavements is to not have an impermeable surface where water runs off it, but rather build a pavement where water is going to be able to go down through the entire pavement surface.
Great. In the second session, we'll be talking about design and construction details. Can you give a brief overview of typical permeable pavement construction?
Typical permeable pavement, those are the surfaces of them. The typical permeable pavement has several different layers of construction on it. This photo is from the UK, and you can see that basically we've got, in this case, they were putting on pavers, stone pavers. Right-hand side, we've got a curb, so we're separating our permeable pavement from an area of probably non-permeable pavement surface. In the foreground of the picture there, you'll see it looks like a black sheet. It's a geotextile. They're using this geotextile in this situation to separate that big aggregate you see in the front of the photo with the underlying soil. Soils are typically over there kind of clay nature, and what we really don't want to have is put this big rock on the bottom and then we have traffic going over it and we end up pumping up some of that soil from the bottom, and because you've got water going through the structure, it's usually wet and it's kind of more like toothpaste, And so we're trying to separate the two layers from each other so that while we allow water to go through, we're not allowing the soil materials and stuff to come back through it. The green sheet in there is actually another geotextile layer that in this case they've decided to place on top of the large stone. That large stone is like railway ballast. It's a very large size. When you put it all together, there's just more or less one size aggregate, and so the space between the aggregates is what holds water. So we've got about 30 to 35% porosity, open space, and that's what stores water in the pavement section. Behind that, the browner layer is a base layer. The coarse aggregate in the foreground, it's difficult to build a smooth pavement on top of it, so typically we use a base layer of an aggregate to fine grade it to make sure we get all our fine-tuned grades. That aggregate is also open graded. We allow water to go through it, and so by doing that, then we can provide the pavement surface on top of it.
It always comes down to a good foundation. So in the third session, we take a look at how to design for performance. What do you think are the key factors for success?
Key factors in making these things work. Number one, a lot of it is like normal construction, but then again, a lot of it is a little bit more specialized than normal construction. Number one, specifications. We need to ensure that we have the right specs and that they're enforced. There's many cases where I see there's somebody in Dubuque, Iowa who's got a spec to install permeable systems, and then somebody in Orlando, Florida decides to borrow those specifications and use the same things. There are differences between geographic areas, differences in construction practices, and necessarily you should just go off and grab somebody else's specs and use them. The National Asphalt Paving Association, the American Concrete Paving Association, the Interlocking Concrete Paving Institute, all have guide specs that you can go to the website, you can download these things, you can modify them to suit for your particular applications and what you want to see. Strongly recommended you go to these organizations because they're advocates for permeable pavements across North America, and they've done and gathered a lot of information here from those sources to be able to produce specifications. I say pay particular attention to the surface and ensuring that the surface material is the first thing that's going to meet the rubber on the road. You want to make sure that you have a hard, durable surface. You have a consistent surface. You don't have things like segregation happening where you get a lot of the coarse particles in one spot and finer ones in another. It's the surface you're going to see first. So we got to make sure that it's well cured, it's a solid and durable surface. In the paver situation, you've got to have proper chips in the joint. So it's very important, obviously. Cleanliness of the job site is something that is more important than it normally is. We don't want to have a finished permeable pavement system and all of a sudden having a load of dirt dumped on top of it. It's going to clog the system. It's not going to work. I'll show you a couple of pictures later on of situations where that has happened on a job site.
Thanks. That gives us a good sneak peek into what we'll be talking about in your series. Well, that's all we have time for today. You can sign up for this Permeable Pavement Masterclass series at foresteruniversity.net, as well as Dave's other roadway webcasts and our library of 175 courses, or check out Dave's other clips at our Forester University YouTube channel.